here we are, in the middle of the wild. We're sneaking up on a very rare creature. It's in almost all vertebrates. The lung. We're sneaking up on it in its natural habitat. Let's see if we can unmask it. We're gonna sneak up on it. I gotta distract it. There's a stick there I can distract it with. Let's go. Ah, it's the lung! Lung facts. The earliest organisms diffuse oxygen through their skin and other moist membranes. Lungs help us survive on land because they replace our skin as a moist membrane.
Lung facts. The epiglottis is a cartilage flap that closes when you're eating food, so food and water doesn't get into your lungs, and it opens when you breathe in. The diaphragm is a muscle in our chest that controls the volume of our lungs. So when the volume of our lungs increases, that lets in air due to Boyle's law because there is less pressure inside the lungs. And then when the diaphragm decreases the volume of the lungs, there's more pressure in the lungs, so the air keeps flooding out because air wants to go from areas of high concentration to low concentration. So, countercurrent exchange. Because water has a lot less oxygen than air, fish needed a way to increase the amount of time oxygen can absorb into the blood from water. And one of the ways they achieve this is through something called countercurrent exchange in their gills. So how this works is fish naturally swim against the current, not all the time, but when they do swim against the current, when the water from the current is going into their gills and through their gills, and then blood is picking up the oxygen from that water. If you're swimming against the current, fresh water is coming in continuously, and because it's fresh water, it has a higher oxygen concentration. So because of this, countercurrent exchange is very efficient. Brian Rogers out.
Maintaining homeostasis. When cell respiration occurs, an excess of carbon dioxide is produced, which is then released into the bloodstream. The negative feedback loop associated with the lungs is registered through chemoreceptors in the brain. The brain receives messages from chemoreceptors when carbonic acid, which is formed when carbon dioxide released in cell respiration, bonds with H2O or water in the bloodstream. This carbonic acid cycle causes the brain to trigger an increase in lung respiration, which brings more oxygen into the bloodstream, which fuels cell respiration, creating a negative feedback loop.
Facts. Brian Rogers here with some interdependence facts. Let me hit you with one, alright? Nervous system. What do you think it does for us? What do you think, huh? We told you earlier, man. It tells us when the pH level in our blood is too low or too high, so we can alleviate that. Why aren't you listening, man?
System, calcium, bones, strong, milk. What do these have in common? Absolutely nothing. But the skeletal system protects me, the lungs, from being crushed. You know how? Ribcage. Simple, yet so elegant. All those things are white. Pulmonary vein, pulmonary artery. What do these mean to you? What do they mean to me? They carry blood to and from the heart. Yeah, the heart. What system is that part of? Circulatory. Yeah. Immune system. Self-defense. What do these have in common? Self-defense. That's what they do. Alright? White blood cells are the heroes of this body. You know why? Because they keep me from dying.
Macrophrase 12316!
Died from HIV. the respiratory system and the muscular system actually interact in a very special way. The diaphragm, when you breathe in, moves down, which increases volume and therefore decreases pressure in your lungs. When this happens, your lungs receive oxygen intake because the oxygen moves from high to low concentration. When you breathe out, the diaphragm moves up again. So the volume goes down and the pressure goes up. And again, the oxygen moves from low concentration, so the oxygen moves out of your blood.
3, 2, 1.
Got a blast!